Good afternoon, everyone. Can you hear us okay? Awesome. Welcome to the room that simulates 2001: A Space Odyssey. It sounds like they have a lawnmower on the roof, but that's okay. We will make do. So good afternoon. Thanks for joining our session. I want to kick us off by asking a question of the room so I can get a sense of who we're talking to this afternoon. Can you raise your hand if your company uses Databricks and you have a platform team that helps you maintain it? All right. Well, Tara and I are here this afternoon to tell you why our platform team is better. Just kidding. I'm only saying that because Tara and I are both in that organization. So I'm Connor Brown. I have about 7 years of experience across DevOps, platform engineering, and security. I just recently wrapped up a year working on our MLOps team just to change things up a little bit. And I just moved to our Gen AI acceleration team.
I'm Tara Enright. I actually started in data science 5 years ago. So I was a data scientist for 3 years. I worked on ML model development. I worked on pricing optimization. My old boss is here. And now I moved to engineering for the past 2 years. So I've been in the core data space working on like core commercialized data assets for Kroger. And then for the past year, I've been on MLOps and our DevOps team.
So Tara and I are both proud employees of 8451. If you don't know what 8451 is, it's the longitude of Cincinnati, technically negative 8451. So we're the data science arm of the Kroger Company. The Kroger Company, we have many banners across the United States, and we primarily serve Kroger in the capacity of retail data science, insights, and media. We've been driving huge value for the Kroger Company for just over a decade now, through data science, and we have several hundred Databricks users at our company, most of whom are onboarded to the platform via the tool that we're going to talk to you about today, which we've affectionately named SciCLOps. So here's what we're hoping that you're going to learn from our talk today. First, how do we enable so many data scientists, data engineers, ML engineers in Databricks with a pretty small platform team? There's fewer than 10 of us on the team. What does a good CI/CD workflow look like for Databricks resources? Hint, definitely check out Dabs. Do we have any Dabs users, early users in the room? Okay, a few, so we're gonna talk a little bit about Dabs. And how can I take advantage of new Databricks features to improve my workflows? And one quick disclaimer about our talk. Although we are gonna focus a little bit on ML-based patterns, we do support any other Databricks workflow through SciCLOps. So that includes DLT, Databricks job workflows, as well as reporting dashboards and future patterns at 8451. So pretty much anything that would be supported by Dabs is now supported by SciCLOps. If you're not familiar with ML workflows, that's okay. You don't need to be familiar with them to understand the talk. But I'm going to give it to Tara so that she can give you a quick overview of what an ML workflow looks like on Databricks, just as a refresher.
Thank you, Connor. Okay, so we are going to talk a little bit about the ML lifecycle to start. So just a little refresher for most people or a primer for those who are not familiar with it. So if I'm a data scientist in the industry, you might have seen something very similar to this before. This is kind of the traditional data science, machine learning lifecycle that we've all kind of done. So say I have a data set, I have my business problem, I'm gonna start with some feature engineering to get an actual feature set ready for model training. Then kind of move to that model dev phase. So that's really deciding on what my core features will be, doing EDA, looking at correlated features, getting rid of some, et cetera. Then I'm going to train my model to my hyperparameters, et cetera. I'm going to store my model next. So maybe I store it as like a pickle file on DBFS. And then after that, I'm just going to continuously call that pickle file every time I want to score my model, right? So I'm going to reach in, do the scoring, give the output, et cetera, until I want to retrain my model. So that is pretty much the traditional life cycle. And then when you retrain, you start again at the feature engineering stage. What is all of this kind of usually driven by if you're a data scientist out there? The infamous driver notebook. All of us have done it. If you're a data scientist, it's great. If you're doing experimentation, I've done it a ton of times, or if you're kind of a small team. But when you're trying to scale across 200-300 data scientists, which is who we support at 8451, you're going to run into bottlenecks. In fact, we found that it took us about 2 to 3 weeks per science deployed for the data science team to engage with their engineering counterparts to actually get their science to production. So having the engineers upskill on the code base, having them learn the nuances of the science, making sure you retain the sampling of the data, et cetera. this was a huge opportunity for us, and so we decided to take a different lens to our science production. That is machine learning DevOps style. So DevOps stands for developer operations. It's really aimed at accelerating delivery, kind of streamlining communication, and shortening that developer lifecycle in classic software applications. So when you take it and apply it to ML, you get MLOps, so machine learning operations. And when you actually go through the list and kind of apply like CI/CD, that build, test, deploy stage, some infrastructure behind the scenes, what you might get in traditional ML is going to be put your code in source control. Let me use a PR, push it to the remote repository. It'll have a bunch of automated tests running. Maybe you're going to validate that model within the testing phase. You're going to actually end up deploying it to somewhere like Databricks. So a platform can be maybe Kubernetes as well if you're doing that. In that phase, you can also do deployments to dev to prod, right? So for traditional machine learning, you can automatically promote it from the dev environment, which maybe you're doing some like feature, quality, data drift, and dev. You're gonna promote it to test once it passes those tests to stage. And in stage, you can have something like a full integration test. And then before it passes to production, you have to make sure that all those checks pass along the way. No more copying between dev and prod. I ran into a data scientist a few weeks ago that did the copy paste from dev to prod, which is classic. We got them on SciCLOps instead. You're also going to have standardization and reproducibility, and that's super important when you start thinking about governance, right? So think about like all those new laws that are coming out, like in California, what's happened recently with the EU AI Act. You want to be able to reproduce those models. So like version your models and also tie it back to the version of code that produced that model. So it's super important if tomorrow, say, a new law comes out and you need to roll back a model version and a code version. With the DevOps style of machine learning, you can do that. And there's also some more things like automated monitoring, data drift, et cetera, stuff like that. One important call out on the registration piece, we won't really talk about it, but we have used Unity Catalog, which was huge for us. So if you haven't looked into it, as far as MLflow plus Unity Catalog, super recommend you do. And one thing we also will not talk about is data, specifically feature stores, but you could add this to it as well. And in Unity Catalog, you have that whole lineage. So recommend you look at those products if you have not. So you might be looking at this and thinking, this will take me 2 to 3 weeks to build, and you are telling me it could be faster. But that's where SciCLOps comes in. So SciCLOps stands for Science Creation Light Operations. It does have a name behind the acronym, and it's essentially our DevOps templating tool at the company. So 2 main pieces, it's a Terraform provisioning. So if you don't know what infrastructure as code is, that's okay, Connor will go more into it. And then it has a second part, a Github Actions template that gets applied to every single repo that we create. So how will this help you? Let's just say you're the end user, you're sitting over there all the way on the left, you put in a ticket through like our service portal ticketing system. Okay, great. Behind the scenes, Terraform's gonna kick off a bunch of resource deployments for you that you don't have to worry about, and Connor's gonna go more into. In the end of it, one of the things you get is a deployment-ready repository. So all you have to do is put your experimental code in, and you're already ready to deploy to Databricks, and it gets deployed on the pull request trigger. Important part here, if you look over at GitHub Actions, as we use, all the way down to Databricks deployment, that middle step is Databricks Asset Bundles, which we will talk more about, but that is how we are doing the Databricks deployments. So it's really simple. We used to write all that code ourselves custom, so relying on Databricks Asset Bundles instead have been huge for us and huge for getting more adoption throughout the company. So we have about 200 deployments throughout the company right now. And we also, you can't really see it, but you can go from idea to deploy in under 10 minutes at 8451, barring testing, of course. Like if you have long-running tests, it might take a while to deploy, of course, but you can go from, I have an idea, I have some code, let me put in the service ticket. All of your resources will be created for you within 10 minutes and ready to deploy to Databricks and work in Databricks. So with that, Connor's gonna talk a little bit more about how it works.
Thank you, Tara. So we're going to dig into a little bit of exactly what is SciCLOps and how does it work. So there's 3 primary components of SciCLOps. We start on the left with the service portal. If you're more from an engineering background, you might think of this as our front end or our user interface. So the service portal at 8451 is ServiceNow. We have a form that we have built out in ServiceNow that a customer can find in the service portal and provide some basic information about the project that they'd like to start working on. And I'll show you an example of what that form looks like in just a few minutes. We ask for some pretty basic things, like what type of data do you need access to? What is this project called? Perhaps most importantly is who owns this project? If you are close to maintaining Databricks, you've probably experienced times when we have some notebooks out there, we don't really know who created them. We might have some lineage, but we don't know if they're still needed or not. So we collect some metadata up front to help us understand, maybe in the future, this hasn't been touched in a year. Can we clean this up to make room? Then we move on to our automation engine, which in our case is Terraform. It's named after Terra. Just kidding. Terraform is something that receives a request from the service portal, and it actually begins building out the infrastructure required for the project. So Terraform is making something like 80 to 90 API requests for us to build out the infrastructure required. And I'll show again a brief demo of what that looks like. And finally, we have the GitHub Actions reusable workflow. Anybody GitHub Actions users in here, or maybe GitLab, something similar? Cool. So a reusable workflow in GitHub Actions is a way that you can build out a workflow and share it across many users at your company. So that's something else that the SciCLOps team maintains, so that after we provision infrastructure, we can also help people use that infrastructure, which has been key to the success of the SciCLOps project. So on day one, I'm going to use the phrase day one and day two a lot. On day one, you have all of these things. You have the GitHub Actions reusable workflow that helps you deploy to your infrastructure. And as of recently, we've started giving them some starter code that is powered by dApps to do the actual deployment. So this is a little bit of a visual of what I was just talking about. So you start on the left, we have a ticket that gets submitted by the user via that ServiceNow form. And the Terraform provisioning is using several different APIs, 4 of which are listed here. One being GitHub to provision that repo, as well as some environment variables and secrets, such as a Databricks PAT, which is generated on behalf of the user for a service principal, as well as Azure, where we put a storage account for maybe setting up Unity Catalog in the future. And we use something called Cookie Cutter to template the GitHub repo with some boilerplate code. And then on the far right, we see what that reusable workflow looks like, where we have a user that checks out the code at the very bottom and starts a pull request with some new modeling code. They open the pull request, and GitHub Actions then triggers using our reusable workflow to deploy to Databricks for further testing. And this is just one example of a workflow that a user might implement with SciCLOps. So I'm going to talk a little bit about that day one and day two concept that I mentioned, because this is a very important part of SciCLOps, and frankly is how we've been able to get a lot of business buy-in to the product. So that day one is the day that we provision a project. As Tara mentioned, we target less than 10 minutes from idea to deployed. And what that really means is, say I have an idea, I need some ad hoc space to work in Databricks. You can fill out that form 9 times out of 10, unless you're requesting access to classified data. There's no approval process. It just provisions the infrastructure for you. You don't need to talk to a person to get started in Databricks, and you're good to go. Then on day two, this is where we start maintaining the project, and in some cases, we deprovision them if they're no longer needed. So day two is sort of the bread and butter of what the SciCLOps team spends a lot of time on now. So for example of a day two problem, I'll call it, that PAT that we provision for users expires at some point, right? Because you don't want those to live on forever. So that's something that we're able to maintain with our automation engine, which is Terraform. So 60 days, 90 days, whatever the standard is, later, after that PAT has expired, we're able to rotate that PAT for the user, and they're none the wiser, because that environment secret is maintained in GitHub by our automation engine, and it's able to update it again later on. And as I mentioned, there may be plenty of projects out there that just get provisioned and don't go anywhere, and they decide that they don't need them anymore. So they can destroy their project with SciCLOps by just submitting a request to our team. It only takes us about 30 seconds to kick that off. So we're going to clean up the GitHub repo, we're going to clean up the environment variables, the service principal. All of those things can be cleaned up very quickly. So I'm going to give a quick demo of what that form looks like, as well as what the automation engine does after we submit the form. And I did want to mention, too, that we are going to open up to Q&A at the end if you do have questions. So this is our service portal. You can see it's a pretty straightforward form. We don't ask a lot of questions. The first is, who owns the project? For example, this is me and Tara. The second there is what AAD group or Azure Active Directory Intra ID now group should own this project. And the next is, what's the name of the project? In this case, just a demo. Finally, we support using GitHub Teams for approving pull requests after the repo has been created. as well as additional named users that are responsible for creating pull requests. So this is something else that we've done. We've added some baked-in GitHub best practices with SciCLOps. Oftentimes, you may never consider that in a project, but our company does encourage that you have pull request requirements, you're protecting main, those types of things. So those are things that you get out of the box with SciCLOps. It's all set up for you. And finally, that last question is more or less asking, what type of data do you need access to? So after I've submitted that form, our automation engine, this is Terraform, is going to start executing what's called a plan. So it's going to take all of the information that it just received from the form, and it's going to say, what do I need to create to meet the request? So this plan is going to run, and then we're going to see that it needs to create, in this case, about 83 resources. That can vary a little bit based on how many people are responsible for approving PRs, as well as what type of data they need access to, because we may do additional role bindings. So at this point, the plan has been approved, and that is not a manual step. That happens automatically for any new project. And the apply kicks off, and the apply is, okay, I'm going to actually go build the thing. This concept is super important during day 2, because there are times that we make updates to SciCLOps. We want to make sure that we're not going to break anything. So the apply runs, the apply finishes. We've created about 83 resources for this simple project. And then I'm going to show a quick demo of what does that day 2 look like. And Tara is going to go into more detail on how you actually use GitHub Actions in just a few minutes. So the business has come to me, the SciCLOps team, and they've said, SciCLOps is great, but we need you to add a new environment secret because our DevOps team requires it now on GitHub Actions. And that environment secret is going to be called Dabs Rocks. So the SciCLOps team needs to propagate that environment secret across a few hundred different SciCLOps repos, because we have quite a lot of them. So what I'm going to do off screen is I'm going to make a slight modification to our Terraform, and then I'm going to, just like a Databricks user would, commit and push that to our Git repo where we maintain that automation. Terraform's going to run a plan again. So this is the same project that we just showed, and this time we're not going to make 83 calls. We're just going to make 12 API calls, is more or less what that's saying, to add the environment secret. This time I do manually approve it because I want to make sure that I'm not accidentally deleting repos or directories. We've had times where people lose permissions, and we want to make sure we're checking for those things in the plan. So this is helping us safeguard the SciCLOps project. So this is a super important feature of SciCLOps because we're able to maintain all of these projects throughout the lifecycle of the project. It's not just a day 1, you get your starter code in Databricks, and you don't get any further features. So with SciCLOps, we're actually able to, like in this case, add environment secrets if that's a new requirement of the business. So I'm going to approve that apply, and then that's going to run. And then I'm going to go back to GitHub and refresh my screen. And we should see now at the bottom, we have a new environment secret called Dabs Rocks, which is totally true. Dabs does rock. All right, and now I'm going to hand it back to Tara to do a little bit more of a demo on the rest of SciCLOps.
Thank you, Connor. Okay, now that we took a look at day 1 for a user, we took a look at platform team experience. So that's what we would see on the SciCLOps side. Let's take a look at the user experience. So we'll put our data science hat on. You're a data scientist, and you're on a data science team, and the business wants you to make a new model version. You have new data. They want you to retrain your model. We're going to start with the local experience. So I want to make sure that I can experiment on my own. Nothing touches my team resources, so I'm going to use a Dabs deployment locally. So I'll start in PyCharm. Here's my IDE. Up at the top, I just have a dictionary of tags. I've added a new one called presentation, and I've noted it as yes, so we can go ahead and look at that on the model in the end. And if you take a look down inside the terminal, all you have to do, once you have all the setup done, which is really just generating a pat from Databricks and storing it so you can reference it, is going to be a Databricks bundle deploy. It's going to run for you, it's going to check state, it's going to make sure everything looks good, and then it's going to make a Databricks deployment for you from your local machine, from your IDE. So if we take a look at Databricks, this is what happens. These are mine. These are completely mine. I don't touch my team's resources in this case, which was huge for us. We had so many issues with developers creating new branches, confusing things. The production automation had like different branches everywhere before we used Dabs. But Dabs really enabled our teams to have multiple developers on a project and develop an experiment on their own, because Dabs lets me deploy to Databricks and put it under my EUID. So if you see under those jobs, it says dev underscore T123 underscore job names. So that's what that Databricks bundle deploy did. Had a -T dev on it. That's for the target dev environment. So go ahead and prefix all of my resources. So those are all mine. I won't run into my team in that way. And we look at the modeling resources as well. So these are the two models in Databricks. As you can see, the top one is under a service principal ID. That's my team's model. The one below it is mine. So it's prefixed with me, dev, and my EUID, which is awesome. And so if I go ahead and I ran those jobs, you would see that we would produce a new model version completely separate from my team's resources, and I could check that everything looked good, that I liked it, I validated that model. As you can see, we have the presentation yes tag, which is very important. Okay, so a quick bonus. How did I do this with Dabs? We haven't talked about the bundle at all, but shameless plug, we have a part 2 basically of this talk on Thursday in partnership with the Dabs team, where we'll go into more SciCLOps as well. But this is a bundle for Databricks Asset Bundles. It sits in the root of your directory. Forget about everything in it. All I want you to focus on is that little box right there. That's all I did to put those resources under my EUID. So it's super simple. Databricks Asset Bundles has made like the ease of use very easy for us and for our data scientists to pick up, and also very simple for making those like personal deployments to my own name and resources. So now that we have taken a look at the local development experience, we will go ahead and look at how SciCLOps comes in. So say I liked everything, I'm gonna put in the PR to the repo. I put in that PR, create the pull request, and if you go inside the pull request and you go all the way down, if you've never used GitHub Actions before, you will see that inside the review dialog box. So I'm gonna click on that, and that's gonna take me to GitHub Actions. And this is part of SciCLOps. So that's that GitHub Actions templated workflow that we talked about. Every user gets this, so it looks the same. You can add stuff to it if you want. It's completely customizable. But for my use case, I'm going to have a development deploy because I've chosen just to deploy to development. You can deploy a test in stage 2, but I turned those off for now. And I also decided to have my jobs run in Databricks. So I have that deploy development, green check mark, it deployed, and then I have that run data pull job at the bottom that's currently running. So if I go into Databricks, go ahead and take a look, we now have 6 jobs. We had 3 before. The other 3 jobs, as you can see, are under my service principal, and my other 3 jobs just for me are still there. I can destroy those too. You can get rid of them. You can clean up your developer footprint. I just have it in this case because I wanted us to take a look at all 6 of them together. So say that job runs successfully. I've set up all my jobs to run as kind of an integration test. Once those GitHub Actions each job gets a green check mark, it's going to give you a check mark on your PR. So that was on the pull request. When I merge it to main, it's going to kick off a fresh run and then push it all the way up to production. So this might take about 10 minutes for those jobs to run. And then in the end, this is why I haven't GitHub Actions. I need a review from Connor before I'm able to push it all the way to production. That's just the best practice we have. You can note that in the ticket who you want as reviewers in the end. And once he approves that, it gets fully pushed to production. All my jobs run, and I have a new model sitting in production now. Woohoo. So with all of that being said, what did we learn as a team? We're gonna have plenty of time for Q&A too. So as a SciCLOps team, what did we learn and kind of what it made this a success as a SciCLOps product? The first 3 are more people-based, less technology-based, but we started a community of practice, and basically all that was we invited anyone and everyone using SciCLOps at the company. It was responsible for the majority of our adoptions. We started with only a few users, and by really creating that like open space to have office hours, to have live demos from users, we did demos, we asked people's opinion, we attended the Dabs office hours and brought back ideas from them as well. It really accelerated the adoption of our product and built trust as well from our users. Along with that, we have inner source contributions. So Dabs deals with a lot of resources, one of which is DLT. Connor and I are not pros at DLT, but we have pros at DLT using Dabs in the business, and they have helped us build out that portion of SciCLOps. So inner source, obviously super important to do at any company. We also have a team with diverse talent. So I came from data science, Connor from DevSecOps. We have a web app background developer on the team. We have another data scientist. Our manager was a music major in college. So just having a diverse team of talent, especially when you're serving diverse customers across data science and engineering, really helps you speak the language. On the technical side, we have a few things as well. We have a full Datadog integration dashboard for monitoring, which is really cool that someone built on our team. It tracks the usage of the workflow across the company, who's failing. We can literally see if it's a particular user whose workflow keeps failing. We can see in general maybe one spot of all the workflows keep failing. We can see are people actually using SciCLOps, not just deploying SciCLOps, which is awesome. We also have a full testing suite deployed from our Terraform module. So when we make a change to SciCLOps that's a breaking change or a big impact to the user, we will run a full deployment from our testing module, and our testing suite will also run like a full user experience. So a model registration, a pipeline, a job workflow, stuff like that. And it all gets deployed automatically from our Terraform module when we apply it. And then at the bottom, it's kind of hidden there, but also dabs and Terraform Cloud. So we used to build all of the Databricks deployments by hand from scratch before Databricks Asset Bundles came out, which was very difficult to maintain. By relying on dabs, it's made it way simpler for us to adopt and also adapt our business as well with Terraform Cloud. So really finding the tools that will accelerate your production of the company was super helpful for us. And lastly, some thank yous. So we have our whole team on the side at 8451. That's Matt, Jacob, Colin, Ian, Caleb, Jingling, and Venetia. Huge shout out. We also have some key collaborators in 8451. Kyle and Tyler were the original visionaries of SciCLOps. They're the ones who built all the custom code. Connor and I came in on more the dabs revolution part. So huge shout out to them. And then Caitlin, Ken, Greg, Matthias, and Chris, as well as the dabs team at Databricks. They've been super helpful the past year. They've been so collaborative. So thank you, Peter, Sada, and Teresa, and their whole team. Also, shameless plug, we have more talks at the conference as a company. If you want to learn more about dabs, we are also presenting our use case with the dabs team on Thursday twice. So there is more room, I think, at one of those talks. And that's the QR code right up there. We also have 3 more talks. The Elation data mesh one was already this morning, but I'm sure you can see the content later on the website when that gets uploaded. But we also have 2 more today for our journey with Unity Catalog as a company, and then Seamless Flow, which are our DLT users at the company as well. And I believe that's the last slide that we have. So thank you.